Hello everyone, so today we will be presenting about technique for managing blood waste. The technique we'll choose is anaerobic digestion. So before we start, we would like to introduce ourselves. My name is Hana Binti Ahmad Jaelan and my matric number is 207-339.
Hello, my name is Razwani Binti Narazi and my matric number is 205665.
Hello, my name is Rabiah Binti Rosali and my matric number is 207457.
Okay, so today's presentation will include the introduction of anaerobic digestion, and then we continue with procedures and methods, and the last part is advantages and disadvantages. So what is anaerobic digestion? Anaerobic digestion is a process through which bacteria break down organic matter such as animal manure, blood, wastewater biosolids, and food waste in the absence of oxygen. So how does it work? The process takes place in an oxygen-free digester where microorganisms such as bacteria and archaea break down the organic matter. There are four main stages in the process, and each stage breaks the matter into smaller and smaller parts until the only remaining substances are methane, carbon dioxide, and water. Next slide, please. So at the end of the process, we have a mixture of methane and carbon dioxide, which we call biogas, and water, and some organic materials we call digestate. So biogas can be used to produce heat and electricity. It can be used in combine of heat and power to produce CMP, which is gas engines, or it can be burned to produce heat only. Alternatively, biomethane can be produced by removing the carbon dioxide from the biogas. The biomethane has many valuable uses. It can be injected into the gas grid as renewable replacement for natural gas, or it can be used as vehicle fuel. Digestate is a nutrient-rich substance, contains high amounts of nitrogen and phosphate that has value as an agricultural fertilizer or soil conditioner. Next slide. So now let's look at the biochemical process. So anaerobic digestion happens in 4 stages. The first stage is hydrolysis. It is the slowest of the 4 degradation steps. Bacteria transform complex organic materials to liquefied monomer and polymers. The second step is acidogenesis. That's where sugar and amino acids are converted. The third step is acetogenesis. That is where the substances are then transformed into hydrogen, carbon dioxide, and acetic acid. Finally, the last step is methanogenesis, where the metagenic bacteria convert hydrogen and acetic acid into methane and carbon dioxide. Typically, the gas mixture will also contain hydrogen sulfide. In volume percent, methane amounts to about 60%, while carbon dioxide is around 40%. Hydrogen sulfide is usually lower than 2%. So now I will pass to the next presenter.
Okay, thank you. I will continue the presentation. Okay, after hearing by Hana about the stage, I will go through in more detail. So there are 4 stages in anaerobic digestion: hydrolysis, acidogenesis, acetogenesis, and methanogenesis. So let me show you what those stages entail in dealing with blood waste. Okay, this is the flow chart of anaerobic digestion. Start with the blood waste, and then the blood will be hydrolysis until to the last stage, which is the methanogenesis that will produce the biogas. Okay, so as we all know, blood is the organic substance made up primarily of protein. So in this anaerobic digestion, I will tell you about the protein component. Okay, so this is the 4 types of bacteria that we'll need in this anaerobic that is required in this anaerobic digestion. For hydrolysis stage, the bacteria that is required is the hydrolytic bacteria, and for the acidogenesis stage is the fermentative bacteria. And for the acetogenesis stage is the fermentative bacteria, and for the methanogenesis stage is the methanogenic archaea. Okay, so we go to the first stage of the anaerobic digestion, hydrolysis. We know that blood is made up of protein. So in hydrolysis, the hydrolytic bacteria will secrete extracellular enzymes that converts protein into amino acids. Okay, that's all in the hydrolysis stage. And then we move to the second stage, is the acidogenesis process. So acidogenic microorganism can produce intermediate volatile fatty acids by absorbing hydrolysis products through their cell membranes. And then the biodegradable material like protein are further decomposed by the fermentation bacteria. So as a result of the acidogenesis process, volatile fatty acids, ammonia are produced. So the volatile fatty acids are type of organic acid that consists of acetates and larger organic acids like the propionate and butyrate. Okay. And then for the third stage of anaerobic digestion is the acetogenesis. So the products from fermentation are converted into hydrogen and acetic acid. So to produce acetic acid, acetogenic bacteria need oxygen and carbon. So in this acetogenesis stage, the volatile fatty acids and other intermediate are converted into acetate along with the production of hydrogen. And then for the last stage, which is the methanogenesis, in which methanogenic microorganism will consume accessible intermediates to produce methane and byproduct carbon dioxide. So blood is high in protein, resulting in high methane yield. So the end of methanogenesis occurs when biogas production ceases, which can take up to 40 days. Thus, we got the biogas. So biogas energy is primarily composed of methane, can be used to provide heat, generate electricity, and other things which can benefit us. So that's all for me. I will pass to the next presenter.
Thank you, Rabiah, for the explanation. I will continue with the advantages and disadvantages of anaerobic digestion for blood-based treatment. The process of anaerobic digestion has many benefits. The first one is reduce the odor below unprocessed waste odor level. A well-known drawback of the spreading of raw slushies on land is the unpleasant smell. Anaerobic digestion can reduce odor nuisance during the land spreading by up to 80%. Second one is low biological yield. Third one is greenhouse gas reduction. Reduction of greenhouse gas by applying anaerobic digestion to the waste and capturing the utilizing the biogas, emission of methane to the atmosphere and the greenhouse effect of this methane are avoided. The fourth one is nutrient retention. Almost all animal waste, including the blood, is spread on the land in some form of another. Undigested fertilizers suffer from the fact that much of it is either lost or rendered unusable by the plant. Anaerobic digestion can increase the amount of nitrogen. The last one is the production of methane. Anaerobic digestion produces methane, which when combusted can be used to produce heat and power. The production of methane-rich biogas, which offer a renewable alternative to the consumption of fossil fuels, is an obvious advantage of anaerobic digestion. While there is many benefit of anaerobic digestion, there is also disadvantages in this process. The first one is long startup and retention. It takes longer to start up the process due to the slow growth rate of the methane producing organism as compared to aerobic system. The second one is require constant monitoring. Anaerobic digestion also require expertise to oversee the operation. A true understanding of the process nuance is required for the successful operation. The third one is shock and variable can change the microbial balance. The last one is high operation cost. It requires a high level of investment in large tanks and other process vessels. Next slide, please. So this is the question And so this is the question that we prepared. The first one is, what are the end product of AD process? The second one is, what does anaerobic digestion require? And the last one is, what is biogas? So that's all from us. Thank you.